This is problem 10. So in this problem, we're told that we've got the temperature time graph and we need to use it to work out how much power the kettle supplies. So we're told that the volume of water is 2 litres, which tells us that the mass of the water in the kettle is 2 kilograms. And we're going to need to use a couple of equations. We're going to need to use that power is equal to energy over the time, and energy in this case is in the form of heat, so Q on T. And we also know that heat is related to the change in temperature through mCW times the change in temperature. So combining these two, we've got that power is equal to mCW times the change in temperature over time. So using our graph, we know that the gradient of the graph is equal to the rise of the graph over the run. Now, the rise is equal to the change in temperature, that's what we've got along the y-axis, and we've got the change in time or the length of time along the x-axis. So let's measure those as accurately as we can. Let's draw a vertical line up from 200 seconds to this point here, and then to get the temperature at 200 seconds, we'll draw a horizontal line across to here. So we've got that's at 62 degrees C there. So the change in temperature, we're going up from 20 to 62. So that's the final temperature 62 minus the initial temperature 20 over the change in time. The final time's 200 seconds and the initial time is 0. So that's our change in temperature over time. Now rearranging this equation here, we can see that the change in temperature over time, we've got to divide this by mCW. So this is equal to P over mCW. And so we can say this is equal to P over mCW. So what the question's asked us to find is this P. So let's rearrange this part of the equation to find out what P is. So P is equal to mCW times 62 minus 20, so that's 42 over 200 minus 0, so that's 200. So substituting in, the mass of water is 2 kilograms, so this is 2.0. The heat capacity of water, we're told, is 4,186 times 42 over 200. So solving this on the calculator, we get 1,758 watts. But we were only given the volume to 2 significant figures, so we should give our answer to 2 significant figures. So that's 1,800 watts.